What we need to talk about are some things that are known as power series. And just as the name suggests, these do involve powers. And they are powers of x, and they are series. And the most simple one of the power series would look like this. It's a summation n running 1 to infinity of x to the nth power. So what's changed here from what we were previously doing? Well, previously we were doing something like the summation of maybe 5 to the n over, I don't know, n factorial, n equals 1 to infinity. Previously, the series we were doing did not involve x. Now they do. Okay? Now they do. Some of these will lead us back to some of these, but the change is here the variable x. And usually what does the x represent? X is a variable, right? X can be numbers. So x could be 1, 2, 3, 4, negative 3, negative 5. Same thing, same idea. However, here's what we're going to be concerned with. And of course, if we write this out, what really am I talking about? Well, my index is running n 1 to infinity, so this would be x to the 1 plus x to the 2 plus x to the 3 plus dot 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 x to the nth, and then on after that. If we write it out, that's what it looks like. So you see why we call this the power series. Because we're talking about x to powers, or there'll be, of course, this is the most simple one, so there will be some complications to it, but all in all, we're talking about x to powers, or the variable x expressions to powers. Makes sense to call this power series, right? Okay. Now, here's the thing about this simple little power series here. Do you see here there are numbers for x for which this series would converge, and there's values for which this series would not converge. They would diverge. So let's think about that. For which values of x would this series converge? Well, do you see that it really amounts to, I'm just talking about the n. Remember when we had the nth power, just nth powered series? What were those series? What kind of series were those? If I had, forget this one. So if I had, depending upon, this is my x, so I'd have a series like that, possibly a series like that. Geometric. The power series, this simple power series, we're talking about the geometric series. Just x could be any of the geometric series there. So, since you know we're talking about geometric series now, for which values of x would it converge? Which values of x, which bases does the geometric converge? Between -1 and +1. Yeah. That's really kind of the idea here that we're looking at is, yeah, we got this power series, and this one we figured it out a little differently than we will do later. But yeah, this power series converges only when x is between -1 and +1, because it's a geometric series, and that's where geometric series converge. Okay? Now, another way we're going to write this is the absolute value of x is less than 1. This means the same thing, doesn't it? It's just a different way of writing that. The absolute value of x is less than 1 means x is between -1 and +1. Means the same thing. Doesn't it? Doesn't this mean that? It means the same thing. The values of x here that satisfy that are the same values of x that satisfy that. Means the same thing. Okay? All right. So we'll mention more about that in just a second. This, I'll go ahead and mention. This, by the way, is known as the interval of convergence. The interval of convergence. It's just for which values x converges, interval of convergent. Then also putting it in this form right here also helps me talk about, if I asked you a radius, what do you think a radius here would be associated with this? Radius of, it's called the radius of convergent. Well, radius kind of carries the idea of how far out you go, right? If you think about the circle, it's how far out from the center you go. Well, the same idea. The radius of convergence is how far it is from halfway on out, basically, of your interval. Because these power series are a lot of them are going to be this way. So we're going out. If you think about the x-axis, number line, the center where it would be at 0, and so this radius of convergence is halfway from the middle out. It's the same thing. So what is the radius? Well, it's 2 units long, so the radius would be 1. And might as well point out here, it's usually, if you put it in that absolute value format, the radius of convergence is usually that. Because this won't always be centered at 0, so you can't just say it's your endpoint, your right-hand endpoint, because you'll see. But anyway, just so you know. All right. What are some others that these power series might look like? Well, what if I had the sum n equals 0 to infinity, square root of n plus 1, x to the n? First point of all is n doesn't have to start at 1. It can start at 0. It can start at 2, depending upon what they want it to be, I guess. But in this case, it doesn't have to start at 1. It can start at 0 or other numbers as well. The other thing is, with your x to the n, you can have other parts. All right. So in this case, I've got the square root of n plus 1 times x to the n. Well, that series would look like what? Well, if I expand it out, it'd be square root of n times x to the 0. Just plugging in, square root of 1. As I start with n equals 0. Then I go to n equals 1. N equals 1, I'd have plus the square root of 2 x to the 1. Then the third term, n equals 2, would be square root of 3 x squared. And you get the idea. Square root of 4x cubed, blah, blah, blah. nothing too far out there. Here's one though. We can also do some other stuff with x inside the parentheses there. In this case, I had the power series, but the base, if you will, is, I've changed it up. So there I'm talking about the powers of x minus 4. X minus 4 to the first, x minus 4 squared, x minus 4 cubed. Pretty easy one, but just note there we can do a little shifting, if you will, of my x. All right, so in general, here's what a power series can look like. It's either a summation, n equals whatever you want it to equal, 1 to infinity, 0 to infinity, 2 to infinity. Then you'll have, some of them will have x to the n, and some of them will be times, they usually denote it c sub n. Where the c sub n is just some expression of n. So that's kind of what we got there. But you could have summation n equals 1 to infinity. Cn x minus a to the nth power, where yeah, we're subtracting some value of x. All right. So that's kind of the intro to here, to power series. What we're going to be interested in finding with power series is what we did with the first one, that interval of convergence. That's going to be the name of the game for power series. Finding the interval of convergence. Where does that particular series converge and where doesn't it? All right, so here's what we're going to do. Number one, find the interval of convergence for this series. N equals 1 to infinity, negative 1 to the n minus 1, x to the n over n. So we've thrown in a couple of things there. Thrown in the alternating series part of it. Then I've also took the x over n and divided it by n. Well, that's going to change, what it amounts to is that's going to change the radius of convergence, the interval of convergence, radius of convergence. Well, the good news is, we have all those tests, but usually on power series we can just rely on one test, and that is ratio test. We're going to use a ratio test here, and that should tell us a lot about where this converges. So for power series, you're looking for convergence, look for the ratio. Use the ratio test. All right, so what does the ratio test entail? What do I look at? I look at a limit of n going to infinity of the absolute value of what? Well, the ratio test is an plus 1 over a sub n, isn't it? I want to look at that ratio. So that's called the ratio test. What does that mean? Well, here's my a sub n. So what's a sub n plus 1? Well, that would be plug in for n, plug in n plus 1. So a sub n plus 1 is going to be negative 1 to the n plus 1 minus 1 times x to the n plus 1 divided by n plus 1. That's a sub n plus 1. Then I divide that by a sub n, which is going to be negative 1 to the n times x to the n over n. Now, what can I first do? Well, the beauty of the absolute values is the alternating stuff doesn't matter, does it? So I can take that out. Now, I forgot my limit as n goes to infinity. The thing is, unlike previously, I cannot take out the absolute values altogether here. Before, I could just knock out this and this because the absolute values knock that out and just say no absolute values needed. However, why can't I take out the absolute values? I have to leave those in. Well, it's because of the x. X is a variable. And x, we're trying to find the values of x for which this works. And x could be a positive or it could be a negative. So the absolute value bars still here are relevant. So I can't take those out because of the x. In other words, I've still got, x could be a negative still. So I've still got the potential here that the absolute values would mean something. And they will. You'll see. With me? So don't take the absolute values bars out. Now the other thing is, I am dividing by that, so it's times the reciprocal of that. But now it gives me something I can work with. What would I do there? Well, it looks like I can do a little canceling, can I? Because x to the n plus 1 is x to the n times x to the first. N plus 1, n over x to the n. I can cancel the x to the n's out, right? Okay. Well, the significance here, n going to infinity, let's write this. Couldn't I write it this way? Because really all that's going to be affected n going to infinity is the n over n plus 1 part. Well, n over n plus 1 as n goes to infinity, what does that go to? I do believe that goes to 1. Divide by n both sides, both parts. So as n goes to infinity, this part goes to 1, and so x is not dependent upon n there. So I'm going to think this limit here as n goes to infinity goes to x, absolute value of x. With me? This part goes to 1, so this limit goes to absolute value of x. All right, so recall that then. What does that tell me? Well, in the ratio test, if this limit is less than 1, ratio test. Tell me the ratio test. Well, part 1 is if the limit n goes to infinity of that ratio, if that limit is less than 1, then it absolutely converges, yes. And that's really the part well, actually I need all parts. Let's go ahead. If it's greater than 1, what about it? Diverges. And what else? One more, because this is significant. If the limit, the absolute value a sub n plus equals 1, what is it? I don't know. Okay? Inconclusive. All right? So by what I found, I can safely say this is absolutely convergent where? Well, it's absolutely convergent if the absolute value of x is less than 1, right? So by ratio test for absolute value of x is less than 1, this series is absolutely convergent. I can also say for absolute value of x greater than 1, what? The series is divergent. But I also have to say for absolute value of x equals 1, I don't know. Okay, I don't know yet. Isn't that what that work there tells me? Since I got the absolute value of x again right here, all I can say right now is this. So there's still a little bit of work to do because of this. I don't know what happens when the absolute value of x equals 1. So I've got to work on that. So here's how I do that. So I have to test these separately. Call them the endpoints. Right, because what we're saying, this is an interval. The absolute value of x is less than 1. That's an interval. It's from -1 to +1. Right, you with me? So I'm looking at -1 to +1. That's my interval of convergence. I just have to figure out what about the endpoints. So I have to do those separately. The ratio test is not going to give me the endpoints. What happens at the endpoints? Okay? So I have to test those out separately. All right, so absolute value of x equals 1, what does that mean? What are the x values for that? X is 1 would work. What else would work? -1. Okay. So I have to test x equals 1 and x equals -1 separately. All right, so x equals 1. At x equals 1, here's the series. I'm talking about this series right here. It would be the series n equals 1 to infinity, -1 to the n minus 1, but I'm letting x be 1. So it would be 1 to the n over n, which 1 to the n is just 1. Okay, with me so far? And we can use previous knowledge here. What do you know about this series? It's an alternating series. What do you know about this part of it, though? That's harmonic, but it's alternating harmonic. Alternating harmonic is convergent. It converges, okay? This converges. If it's harmonic, it's not convergent. But if it's alternating harmonic, it is convergent. So at 1, it converges. So we've got another little point to add to our interval. Converges at 1. What else, though, do we have to test? -1. Our series then would be -1 to the n minus 1 times -1 to the n over n. That one I don't think we have talked about. However, let's look at a few terms of it. What's the first term? Starting at n equals 1. I think we can make a judgment here about that. At n equals 1, we'd have, the first term would be -1 to the 0, so that's +1, times -1 over 1, -1. second term would be 2 minus, so it would be negative 1. Negative 1 squared is positive 1 over 2. So that's negative a half. Third term. Third term is, oh, okay. I could have worked on that a little bit. Third term is negative 1 squared is positive 1, but negative 1 to the third is negative 1 over 3. This is negative 1 minus a half, minus a third, minus a fourth. What is that? What if I factor off a negative 1 off all of this? And maybe that's what I should have done previously. What is this right here? It's harmonic, isn't it? That's harmonic series. So this is the negative harmonic series. What do you think it would do? Well, this right here diverges, and then we times it by negative 1, then that's still going to diverge? Yeah, it's still divergent. Negative harmonic series diverges. I don't think we talked about the negative harmonic series, but the negative harmonic series diverges. The alternating harmonic series converges, but negative harmonic series diverges. Okay? So what does that mean? Well, we got one more piece of convergence at x equals 1. Converges at x equals 1. So that adds to this, okay? So I can't say the absolute value of x equals is less than or equal to 1 because that would include the negative 1 part of it. So here's my interval of convergence. Can I erase that? Has everybody got all that they want? Couldn't I say the interval of convergence then is negative 1, it's less than x, less than or equal to positive 1? Because I include the equal to 1, but I don't include the equal to negative 1. Is everybody with me? Okay. And so that's the basics to testing these power series for the interval of convergence. Now again, going back to one other, what would be the radius of the convergence? Well again, if you think about the number line here, you've got a center at 0. And so the radius is just like a radius is for a circle. It's how far out from that center you go. Radius is 1 here, isn't it? So we'd say r equals 1. And again, in the absolute value inequality here, this number is going to coincide with that. So if you've got the reference there. Okay.